everyone. Thanks for being here. I'm really happy to welcome you to the first event of this series that we're calling Powered by AI, which is really at the intersection of artificial intelligence and the energy transition. And I'm really excited to see that so many of you are interested by the topic. So we want to create this community around these topics. AI is a subject that's been booming for many months now. So is issues of climate change, sustainability, and the energy transition. But we realize that the intersection of both is something that few people are working on. And we thought that it would be interesting to both discuss issues that are related to the intersection of these topics and create a community of people, because we have more questions than we have answers today. And I think the point of these discussions is to explore a bit more. And if you go home tonight with a few ideas that may inspire you to think about later on, I think this will have been a success. So I'd like to thank a few people before we get started. I'd like to thank NG and MIT. So this is co-organized between NG, the digital part, the research and innovation part. We've got Biljana Kerovic, Olivier Sala, and Claire Huezon to thank. We've got the organizing team with Lucille, with Ludovic, Thema, Camille, Christine, Laurent, and Claire, who have organized this event with great diligence. We've got, of course, our speakers today, Margarita, who's director of the Center of AI at Schema Business School. We've got Jan Lechel, who's here from Probable, which is a company that's trying to promote and commercialize scikit-learn, which is a library that many of us data scientists know because it's one of the most used library in machine learning. We've got Yves Le Stanlen, who's president of EMEA of AI Redefined, who's been with Element AI, which is a company that some of you may know, which was started in Canada by Yoshua Bengio, who's one of the great fathers or grandfathers of deep learning as we know it. He was also CTO at Cyrodiil, which is a company that joined NG a few years ago. And I'm really happy to co-host this event with Ludovic Quesnel, who's VP in charge of digital transformation and solutions at NG. So we'll get this started. On the MIT side, I'd like to thank Frédéric Anoye, who's the president of the MIT Club. And that allowed us to create this event really between corporations, so NG and others in the industry, because we'd like to create common discussions around these topics, but also startups and academia. And we've invited a lot of people from various academic institutions today, Columbia, Harvard, a lot of the Ivy League schools, and we want to promote, and some of the business and engineering schools in France as well. We really want to promote this interconnection of disciplines and backgrounds so that we get the conversation going. And finally, thank you to the audience. So we've got a few people online who are joining us from around the world at NG today. And we'll publish the video later on to open it to the public. But it was important for us to have you here physically so that we could get the conversation going. That's why we've got a few goodies at the end for networking among ourselves after the event. And we'd like to get things started. So as a first question, maybe I'd like to set the stage for what we want to discuss. And I'd like to understand what's your definition of artificial intelligence, of machine learning, of deep learning, of generative AI. There's a lot of words that are being thrown around today. Like, for example, if we started with you, Yves, if you were to define for you what these terms mean, how would you go about it?
Okay, thank you. Hello, everybody. Well, I will actually take the definition of the OECD that I kind of like. An AI system is a machine-based system that for explicit or implicit objectives will infer from the inputs it receives how to generate content, so output content, recommendations, predictions, decisions. So that's for the model building. And then you could add that for the use of that model, of course, the level of autonomy will vary, as well as the adaptiveness that will vary also. And those outputs, those models will actually influence the environments. Those environments might be virtual or might be physical. So I think that based on this definition, we capture a lot of the different items that you will find in AI. And we've seen that the generation of the content also captures the generative AI. So those AI systems are, ways to sense the world. So we've got data, we've got, computer vision, you've got natural language processing, you've got time series and all the files you can get in as inputs. And now what, of course, became quite interesting and amazing last year was that we're also able to generate, some outputs that sounds very, very natural for us human beings, because that's based on the language and on the images that we can see, if not the videos. So, there has been several generations of artificial intelligence, and in Europe and in France, we are very strong on the expert system and rule-based systems. And I think that they are very interesting, especially when you have, a bit of regulation, certification, all those industry types of applications, because we've got some constraints. So we know some inputs, we know some outputs, and we can actually explicitly describe what we should get, and then we can tap into that to get the answer. But that was not, of course, super future-proof or changes-proof. So that's why there was this other type of generation that came that were more data-based. And we've seen that in the in the 2000s, 2010 to until now, where we had huge quantities of data, so big data, that helped us actually to really find new algorithms and get some breakthroughs in the algorithms. But that went also along with some computing power, of course, that helped us to manage to handle those huge quantities of data. So these were more the model-based, data-based models that came, that were very popular. And then we started, to have some machine learning, so to give some ways for the machines to learn how to provide those outputs, given some inputs and objectives. And you've mentioned Yoshua Bengio. So Yoshua Bengio, Jeff Hunton in Toronto, and Yann Lequin, of course, we are very strong on this deep learning. So deep learning was really leveraging those huge quantities of data and being able to, in a kind of mimetic way of the neural networks in our brain, to create those neural networks with different layers, and that we're able actually to be really super precise on the way to capture, especially, or to identify, especially images and features in the language as well. Generative AI, we've mentioned that, very recent. I think that what really made the difference was the user interface, the way to be able to interact with this generative AI, to see those images, to give some instructions, some prompts, etc. And I believe that in the future, some of you already know, but in the future you will hear a lot about AI agents. So AI agents are a way to embody some different tasks that are realized by an algorithm, by an AI, and then the deal will be to orchestrate all those different AI agents together with the human beings. And that's what we will create, kind of super teams with humans that will be used in what they're very strong at, meaning, getting a physical sense of the environment, getting maybe some reaction, more context, etc., with the power of those AI agents, super strong at obviously dealing with the combinatory aspect, with the different what-if scenarios to try to make the best decision. So really those super teams based on AI agents will be quite interesting.
So I think what I'm hearing, which is very interesting, is the fact that part of what we think of as AI is dealing with sensory input, both from the receiving end, whether it's text, visuals, sound, etc., and then also being able to either generate them or analyze them and possibly make predictions, classifications, those kind of things that we use AI for as a tool. And then there's a whole branch of machine learning techniques that use data that's not very sensory or human friendly. For example, time series or data that come from equipment that we may be able to process for the ends of helping users make decisions that may affect their environment, but may also affect the way that processes work in industry. So I think the key to that is both on the types of model that we use, from machine learning to deep learning to generative AI, but also on the user interface and the human-machine interaction. And I think that's maybe where we'd like to go with this discussion, towards starting from the models and going towards how do we interact with those models to bring value to different types of personas within an industry.
Mm-hmm. Yeah, absolutely. And in the field, of course, of energy, we've got a lot of IoT or SCADA type of data. Some of them are fantastic. Others are a little bit scarce or, inaccurate. And the trick will be to, not wait to have the best accuracy or super well dimensioned data lakehouse or data warehouse in order to start using those AI models. And again, having a continuing learning with the human in the loop, with the user in the loop, not the builder of the AI models, but the users of those AI models will actually, that's the trend. That's how AI is actually deployed and used when it's really leveraged. This human interaction is tremendously important. And as we've mentioned, we've mentioned those rule-based or symbolic type of AI, those machine learning, deep learning, reinforcement learning, if we want to add that to the list. The trick will be also to combine, to get a hybridation of all those models. And a lot of applications actually don't require big data. And actually, sometimes in reality, most of the times, especially for large corporations and smaller corporations in particular, we don't have a lot of data. So how to do when you have small sets of data? That's again where the human expertise, the domain expertise of the human will be tremendously important. And then we've got, kind of techniques that also help to do that. You've mentioned the domain of Jan with scikit-learn, which is a very long-lasting type of models and products that will be required, and that will be combined with a lot of other types of AI. But we, in the last decade, we've kind of tried to find fantastic techniques based on big data, deep learning, and the like, when actually the problem didn't require that. And we kind of overstep the more classical, I wouldn't say easier, but the simplest models to use, and learning to leverage those kinds of different models is actually how you manage to get from the 10% of AI pilots in the companies to a far more important ratio of successful projects that are deployed.
So let me turn to you, Jan, because you mentioned, Yves, about traditional machine learning, classical machine learning, however we want, boring machine learning, however we want to call it. That's a field that you're currently working on. How do you think that frugality in terms of using models, like you said, let's not use the state-of-the-art top model to solve a simple problem. Let's get to basics. Let's do the math. How do you think about that in terms of libraries like scikit-learn? What's the usage of it? How does it help companies who use it be competitive on the market?
Hello, everyone. So I'll start with a quick quiz. Who's familiar with TensorFlow here? Raise hands. Okay. PyTorch? About the same. Scikit-learn? about the same. All right, good. Who knows that scikit-learn is mostly French? Fewer. So TensorFlow is Google, and PyTorch is Meta. These libraries are pretty much the three libraries that matter in machine learning in general. And what people don't realize is that scikit-learn has been around for nearly a decade, which coincides with the advent of big data. Right? So essentially, the past decade has been the decade of scikit-learn, whereas PyTorch and TensorFlow are blooming today precisely because of GenAI. So if we distinguish between deep learning and traditional, quote-unquote, boring AI, the one that we don't talk about so much these days, is that it's actually deployed in production. So I'm biased. I'm becoming the official operator of scikit-learn, which is a library that I did not build. I have no merit, and I'm not going to pitch you scikit-learn because you know what it is. But the point is that when I talk to people, I use the Pareto distribution by saying that 80% of the use cases out there use traditional ML. Some people correct me. They say that it's 99%, precisely because while generative AI, of course, is extremely promising in the sense that we have seen in the last year interest that is unmatched, probably a true revolution in the making. However, in the enterprise, we do need models that are well understood, that actually derive, recommendations or fraud detection that is based on true understanding, minimize false positives, and so on and so forth. Whereas GenAI is only promising to achieve certain types of results in the space of NLP or image recognition. So the two categories are very distinct, and we need to recognize and also help enterprises, companies, NG, to actually harness the power of data, which Yves talked about, because the hardest thing is to actually nail this issue of collecting the data, making sure that we have the relevant data, that it is cleaned up. 95% of the data scientist problem actually has nothing to do with the machine learning itself. Has to do with everything before that and the company itself, everything after that. So it's a complex issue that is about adoption, translating into use cases, whereas some of the techniques in machine learning is actually just applied math. Nothing new, by the way. Nothing new even in the field of deep learning, because we're all pretty much, I think, slightly above 30 years old of age in this panel, but we're still much younger than AI as a field, because the formulas have been essentially invented over the past 70 years. So we can thank Yann Lequin and the other recipients of the Turing Awards for having sustained their efforts during the different winters of AI. But the fact is that we are only transforming, I think that's your job, right? Transforming companies to adopt the best of breed with things as casual as small data sets. And if we think about the power that is required to achieve performance on smaller data sets, all of it fits on a laptop. You don't require the power of the cloud and the power of a hyperscaler or OpenAI and the bank account of Microsoft, which is $1 trillion company, to actually achieve tangible business results. GenAI does require that. So it's important to make a distinction between the potential of GenAI, which is future, to the potential of traditional AI, which is today. So you need to combine the two, and that's a challenge for you to embrace both what is tangible today and what is promising tomorrow.
Yes, exactly. So, of course, I'm sharing exactly your point of view. What we have in production today is mostly machine learning, and we have mostly POC on GenAI. But nevertheless, we have to work on the future. And for you, Yves, on that, what are the main challenge, or what are the links that you are making between the big data and the LLM on GenAI, and on the application on the 1% that Yann was mentioning? For you, what are the big transformation that we have to foresee?
Yeah, so we've already slightly tapped into that, the fact that what is super important is to understand the type of data that we have, that we can create, that we can get from collection by those sensors at different levels of the operations. It can be at the edge, and it can be, of course, at the office through all the reports, the maintenance reports, the files, etc. And the trick is to understand beyond those data, those models, and those algorithms, what is the process that we have today? Are we able already to capture the existing ways that are operated by the different operators, again, from people in the field to the people in the office? And we can actually, leverage and build some models that will be able to be efficient in terms of productivity at those different levels. But then the trick by coordinating those different models is also to understand what could be the different possible scenarios we could have in order to do things differently. So once we have, and you see, again, those kind of AI agents coming, when you have an AI agent at the edge, you have an AI agent back at the office with the expertise of the people. So then you can create a lot of different what-if scenarios and see what will be actually the shape it will take in order to be able to react to that. And we start seeing that actually in the operations a long time ago, but totally reinforced during COVID. Why? Because we were trying to create organization processes that were resilient to those types of crises, being able to, making sure that it's totally safe to operate. And I'm sure you remember at the start of COVID, when the crisis, arose, we were every month changing the plans and the forecast and the different ways to operate, and it deals with not only the operations but the people, how to organize the people so that they can accomplish their task, and when to restart, when to stop. And that will be something we'll probably touch upon in a few moments in the panel, when we'll come to the ways the grids and the energy production is organized today, where we also need to build some sort of resilience when the supply, so the generation of the energy, becomes very volatile, and the same for the demand. So it totally changes the way the landscape and the ecosystem of the energy is coming. So coming back to this trajectory, I think we've mentioned that already, starting with some basic type of models with the data we had at that time, going through the big data, trying to understand how to use some models on the small data, and everybody is trying to reach the level where you have the smart data. So not necessarily all the data you can connect, but the one that are super relevant to what you want to do. And how to do that? It's not necessarily a machine learning tool that will help you to do that. That's actually the domain expertise. And that's where the things that we see today is that what are the criteria to have successful operational AI models? That's actually to combine not only the data scientists with the data and the way the data is captured, but also beyond the executive sponsor of the organization, that's also to involve at the inception of those problems, of those projects, of those proof of concepts, the domain experts and the challenges that we want to solve with that. I'm sure you've seen, I mean, it reminds me of, the CTO of the German company Bosch, who was saying, oh my God, I mean, I have a lot of pilots. I have more pilots than the Lufthansa in my organization. So, and that was the reality. So why? Because we are trying, and that was good, because that was the time of acculturation. We were, bringing AI in the organization so that people get familiar with that. But now I think this time is over. So, and not because everybody's now totally trained on AI, but because we know what can be used, what can't be used, what we can do, and the processes in order to put that in the organization, and how to create those teams that are multidisciplinary and that will, from the inception, have the goal to solve something, not just to try, but to solve something that is a business issue, that is a challenge that the organization has, and that the AI team will solve.
So yeah, you raise an interesting point, and I think we'll come back on that, which is data, big data versus small data versus smart data. And I think that gets into the loop of model to human interaction to human usage of the AI models. Margarita, I'd like to ask you a little bit about the recent work you've been doing around using AI with managers, both for business purposes and creative purposes. And I think it's interesting because it uses both traditional AI and deep learning and generative AI.
Exactly. So good evening. Following the discussion that Yves opened, I would like, before entering in the creativity and the relationship with the manager, to stress the point that if you are here to talk about AI, you are talking about human-centric AI. That means the AI system that Yves told before, but with a layer of ethics, because it's super important, in particular in the energy field. We are talking about the impact of AI on society, on the energy, on the environment. So there are value behind, and so ethical value. And so how to inject this value in the AI system. Maybe it's easier when you're talking about rule-based and machine learning because it's clear the formula. And so we can interpret, we can say this is good or not good. But when we enter in generative AI, neural network, and there is more level of complexity, and where it's so difficult also for the manager to interpret what is good and not good in the output. And referring to this, we are doing in Schema Business School a research where we have interviewed the manager working in NASDAQ. And so to ask how the new neural networks and the not saying generative AI there, but deep learning and so very complex system are used and need to be used to address the volatility of the market, but how this impacts on their way to work, because they're not able to interpret how the algorithm is built. So that is the real problem. So the technology is in one dimension, one trajectory that is evolving very fast and allows to do tasks very complex on one side. On the other side, don't forget that there is the human, and the human has to control the machine and to identify what is good and not good. So when we are talking about human-centric AI, we are referring the use of AI in an ethical way, so how to inject the value in the algorithm, how to compensate, how the manager can compensate what the machine cannot provide, because we recently published an article in Harvard Business Review US where we mapped 800 AI systems that have different level of ethical implications. And this means that if I consider the AI system applied to healthcare, it could be a machine learning, it could be a deep learning or generative AI, but I'm dealing with humans. And so the manager or the people that is working with the AI system has to compensate this balance that the machine cannot provide. And we reference also to this teaming with AI. And so the team manager and machine, human and machine. One of the articles that it is in press now in British Journal of Management, and it's what you are asking me before, we interviewed more than 500 managers in the B2B in Europe. And we asked, in particular with the service recovery, so B2B is a field that where the use of AI in face of my customer reduce the relationship, because it's better to keep a personal relationship with your client. But what we observed by their experience, how the manager are using AI, is that AI may have different type of intelligence. That could be mechanical intelligence, till the social intelligence, in interaction intelligence, if I consider chatbot. But there is a balance between what the human needs in that stage and what the machine can provide. So it's important to keep the right balance and compensate when the machine cannot do some tasks that are important to the effectiveness of this specific task. That could be service recovery or whatever. Finally, we reference to creativity, and this is a big field of area, and it is one of my main research area that I'm working with a professor in Wharton. We are trying to identify how the artificial intelligence, but more and more generative AI, can make managers more creative. And in that case, we started observing the artists and their use of generative AI and not traditional machine learning, deep learning, or generative AI in order to understand how artificial intelligence impacted on their creative process. And then we also interviewed the manager in field that require more creativity and the fields that require less creativity to see how their practice is changed by AI, is challenged by AI. And we discovered, and this is maybe the main finding, and it is linked with the discussion we had before also, the changes in the way the AI is always a tool. So the tool in the hands of the human, but can be used as a tool, I can use a calculator to make maybe better my work, but it is a tool. Or it can be used also to challenge me to have more idea that could be false, and I have to develop the critical thinking to distinguish what is false and not false, just to open up the space and have more idea, similar when I use ChatGPT and I put a prompt, give me some idea regarding this. Maybe they are false, maybe there is plagiarism, but the output that I can get is, okay, I enlarge the spectrum of possibilities and then I take my decision, and there I need the critical thinking. But there is also a third way to use generative AI, and it is linked with the discussion we had before, to be challenged and so to stimulate the creativity. Generative AI requires to deconstruct my task. Deconstruct, so split in different stages, in different subtasks. And this means that I have to know perfectly my work to be able to tell the machine that there are these different steps. And so the real challenge in this case, I can use AI, the AI can inspire my creativity if I'm fully control my task and I know perfectly my task. In that case, the machine becomes a collaborator. It's a sort of copilot. If we are using copilot, we can understand that it becomes a collaborator, but I have to direct and I have to know exactly the different tasks and the different steps. So to bring this in a discussion, definitely AI, traditional AI or more generative AI, challenge the way we are working as human, and challenge also the way we can interpret what the algorithm is saying, because it can become too complex, or the transparency, the interpretability of the algorithm, maybe it's out of the control of the human. It's important to keep control of this, and it's fundamentally important to become more human, to be able to understand what the error that the machine can provide, of course, is not more than us.
Yeah, thank you. There's a quote by Jan that I'm going to steal, but you're going to correct me. It's not plagiarism. It's that generative AI and LLMs is like literature, and traditional AI is like math. Could you elaborate on that? And could you talk about, just to finish up the chapter on traditional AI and machine learning, the usage of it in terms of explainability, which Margarita talked about, the fact that it's useful because it's open and we understand what's going on, in terms of resiliency, in terms of frugality. There are certain advantages of using traditional AI versus generative AI, which brings other advantages, but then we have compromises to make. How would you comment on that?
Well, basically, if we look what's happening with generative AI, it's a convergence of a number of factors. Number one is the All You Need Is Attention paper from Google in 2018 that changed pretty much everything in terms of how NLP was being dealt with. Of course, this combined with the cloud. We have to talk about the cloud because it's almost the elephant in the room that we don't talk about enough. But the brute force that the typical hyperscalers, Microsoft, AWS, or GCP, not to mention them, is that they allowed this sort of concentration of computing power, mostly around GPUs, around one algorithm that Google came up with, and that created this whole momentum around 2023. Right? So there's a zoom factor around deep learning applied to NLP through this one paper from Google that generated this momentum between 2018 and 2023. Now, the other types of AI is actually well managed, only works on CPUs, doesn't require a lot of power, and is well understood. So this dichotomy is important because these two categories exist at the same time. They are complementary. Some of them can actually help human beings, one of which is more literary in the sense that it is the perfect human-machine interaction, the perfect human-machine interface, because human beings express ideas. And so if the machine is able to understand these ideas, then we can go down to the abstraction level. Whereas in the past, if we were only talking about, say, mathematical problems or specific data sets, smaller data sets, you needed the human to actually wrap their mind around the data to actually make sense of it and create a model that was resilient. So the two categories are complementary. They don't require the same amount of processing power. The latest type of AI requires tremendous amount of power. In fact, the equation from Copilot, if we use Copilot, Microsoft is actually losing money on you at the moment because it's not efficient, requires way too much energy, requires too much computing power, and people are just throwing problems at it. So it's a brute force approach that is really not subtle. Actually, Gen AI is not subtle at all. It's really brute force if we look at it carefully. This will evolve, and I'm concerned, and maybe we'll talk about that a bit later about, in terms of thinking about the stack. What is the stack that is required to do any sort of AI, including generative AI? So that stack currently sits mostly with the hyperscalers who have a tendency to systematically reinforce their ability to provide services to us. And that poses the question of control and mastery, if you wish. Right? The more we delegate to the machine, the less we control it, and the more we delegate to third-party providers, the less we have sovereignty. Sovereignty is a term that is complex at the national level, but it is also complex at the corporate level, and then at the individual level as well. Right? What is sovereignty from an individual standpoint? So all these issues are linked, and of course, the further we go towards traditional machine learning, the more control we have. In fact, the tagline for Probable is own your data science, right? Precisely because we want to provide this ability for human beings to control this sort of AI, the sort of power that is trapped in the data that should enhance us, not replace us. So of course, the co-piloting is wonderful as long as we keep the co-pilot in the co-pilot seat, right? So there is one part of AI that is well understood, so far so good. The new type of AI is going a little too fast for its own good and for our own good. So that is my warning here, and that's where I stop between the dichotomy.
Yeah. Talking about Copilot, and I agree with you that the Copilot has to remain the seat of the Copilot. We have, for instance, for the development, GitHub Copilot, which is coming quite strongly to help the developer. So it cannot replace the developer, but it can really accelerate the work of a developer. And as you like boring, I would say doing the boring task of the developer, like generating all the test cases, etc. So on your experience on Scikit, etc., are you using such tool of like GitHub Copilot to accelerate the development or to reinforce the quality?
So now we're getting into the meta concepts because we're using LLMs to do better deep learning.
Exactly.
So all of that works. The beauty with LLMs is that they encode knowledge very well, and it turns out that software code is easily encoded. Therefore, LLMs are great at producing code. Now, just like traditional machine learning on small data sets have to be really precise, explainable, and so on and so forth, developers will want to review the code to ensure that it doesn't have unexpected behaviors, to say the least. So we cannot trust the machines to produce final code, just like we do not trust code that we used to copy-paste from Stack Overflow. So LLMs are replacing Stack Overflow in a very interesting and dynamic way, actually interactive. So it is improvement on that, very much in the same way that LLMs can help improve data sets. That is a use case that is currently not fully deployed, but very soon we'll be able to take a incomplete or broken data set and use LLMs to augment and fix data sets in order to do traditional machine learning using traditional methods for better models. So that, again, the two techniques are very interesting in combination. We are only at the beginning of it. And in fact, the notion of transformers, so of course, we all use ChatGPT, so we know firsthand what transformers do to language. In fact, the analogy, I like to use that as an analogy because maybe if you've been educated in the American system, you're taught how to speak and present ideas. You're being taught that you need to present 3 clear ideas. And so when you speak, you say, okay, my first idea is this, but you know it exactly because you've memorized it, but you have no idea what you're going to say next. Because your next idea comes from the first one, and the third one just flows. So LLMs are just that. Given a corpus of experience, usually most of what humans have produced in the past, which is a lot of knowledge, then the LLM will produce the first idea and then the second and the third as a sequence. So it's quite deterministic, but it's very poor also, because if it lacks a context, then it's just a stochastic parrot, which is very diminutive. Now, if you apply this idea of sequencing, you can apply it to chemistry. You can apply it to, I heard that Waze, the teams at Waze, they use the transformer models to predict your traffic in the routes. That's not language, but it's code. Sequences, segments of roads are essentially a path from A to B, and that's a narrative in some ways. So it's interesting how LLMs are just the language version of what the transformer models can produce for anything that is a sequence. Code is sequence. Law is a sequence, is code as well. So we can also expect that certain fields will be largely disrupted as a result of that. But again, my focus will be specifically on making sure that at least certain types of machine learning algorithms are well distributed for boring use cases that provide a lot of value today.
Thank you. And as tonight we are in NG, we will talk about a little bit about energy. And so what you say is inspiring me, because I've always think about the issues that we are facing on power, but only with more classical machine learning than Generative. But with what Waze is doing, I'm starting to think a little bit differently. So today in the power market, it's evolving quite a lot. We are going to a very decentralized production, decentralized production, including on the consumer part, which can have a solar panel. Instead of having nuclear plant, you have a lot of wind farm, solar panel, etc. So the balancing the grid is becoming more and more challenging. So we see in NG a lot of value in this teaming between human and machine learning to solve that issue. But you look to have a lot of ideas on that, Yves, at the beginning of the session. So can you elaborate on that?
First idea. You might.
My first idea, no, is that indeed there are a lot of opportunities in the energy sector to leverage everything we've mentioned, and maybe I will. So I've been exposed quite a lot through AI Redefined with one of our customers to the Australian market. That is very special, very peculiar, but quite interesting as well. They decided the Australian government decided to really go full speed on this net zero target by 2050. And there is the Australian powering plan that actually projects to increase the capacity by 32 gigawatt by 2030. And they've also, so they're already 82% renewables, I think. And they've taken a couple of measures in order to really speed up everything, including a lot of financial incentives in order to add more solar panels to their households and to the companies, but also to include more battery energy storage systems, so BESS. And so it's a fantastic opportunity. And they've also added actually law regulation for sub 5 megawatt type of plant. So it creates a landscape that is quite interesting because indeed you have a lot of volatility at the demand, at the consumption, plus those batteries that are there. So it's difficult to predict what they will actually need from the grid, knowing that they have their own solar panels as well. Production level, we are far from the very steady generation of nuclear-based electricity, where typically the grid were forecasting pretty well, knowing very well what the generation was. Here, we have a lot of differences and changes. And when you're an asset manager and when you need to operate this grid, you have a lot of decisions to make. First, you need to, understand and predict a little bit the wind farms and solar farms generation. You have, of course, all your equipment and the related maintenances that come and the allocation of resources to do this maintenance. You have to store your energy in the battery energy system. And but there are a lot of tricks for those batteries because, of course, you want to understand what is the level of capacity that remain, but also you don't want to overcharge your battery in the cycles of discharge because it's linked to the warranty of your batteries, and you want to prolongate the lifetime of your batteries. Then, when you have to provide this energy to the grid, you have the mechanisms, the multiple streams of revenues that can be PPA. I mean, some of you in the energy sector know that. So that's the power purchase agreement. Then you have the spot market. So understand how you provide the energy to the grid based on the demand on the spot market. And then you have the FCAS system that is the frequency control ancillary services. So you have a lot of factors and a lot of decisions to make. So it became just impossible for an operator to have that in a systematic way. That's where actually new tools based on AI came, and with the help of the expertise, the domain expertise of the asset manager, to actually handle the routine type of tasks or of turning off, turning down some of the aspect, but also the human gives context to the AI, and you have a continuous learning. And the context is, for example, we've seen that there is a weather breaking event that will make a coal plant to shut down at some time. So you know exactly that there will be a surge in the spot market. So you want your model to be able to cope with that. If you're actually dealing only with historical data, you won't be able to do that. So how do you team up with your AI in order to inject your knowledge, your anticipation, your context within those tools that's really where the beauty currently is, and how we can team up with those AIs in order to have a better handling of this volatile demand and supply.
So what's fascinating to me is the fact that we're talking about how AI can help the energy transition and dealing with energy, decentralization in certain ways. But energy is also one of the major inputs to AI systems. Like we've said on data centers, there's I don't know how many hundreds, even more data centers being built every year now by hyperscalers. And that poses questions around both the hardware, the energy supply, and the sovereignty of AI. And I think you've done work on thinking about that in the context of governance, in the context of how can we use and think about interfaces linked to virtual worlds in addressing those topics.
Exactly. So another dimension of complexity is when we consider virtual worlds. And particularly, I served as an expert in the European Economic and Social Committee, where we worked in developing two opinions for the European Commission, asking and exploring what is metaverse. They don't call metaverse, it's virtual worlds, and how it is used by companies. So we did a lot of hearing with companies also working in the energy sector to see how they are using metaverse, virtual worlds. And virtual worlds is AI plus blockchain plus NFT, are very complex words. To do what? Already we can see that many companies, also in the car company, can decentralize or do in the digital twin some tasks that otherwise are done in the real life, and this can have a positive effect, also negative effect, as you were saying, with the data center, that the power and the effect on the energy, of course. But there is a mix, a balance between the two. But independently by the task that they can do through the digital twin, so in the virtual worlds, one critical aspect is the new actor that appear, because when I am in the virtual world, even in agriculture or in ecology company, there are also different platforms, so different actors that put together different players, and there are also the technology provider and the data center, those who control the data. It is true in the real life, we see with Amazon with the platform, but in the metaverse is multiplied. So it's not just a technical issue. What I want to say is also a problem of governance, a problem of sovereignty, a problem of data and control of this type of information. In particular, and it was the objective of the second opinion, and we worked on, it was more on which regulation we need. Because when we are in the virtual worlds, there are no boundaries. And so when you talk about governance, is more complex than not just governance of the data, who control the data, and they can protect with different technological tools to avoid that I can control the data, cryptocurrency. I'm not in this field, but to defend the data. Is also the rules that have to be applied. And potentially the player can make a transaction in the virtual worlds, and then there are also fiscal effects because they can avoid to pay taxes. So the governance is larger, is more a governance of the player, a governance not only of the technology applied to do this particular task. That's why that is the open part and the work that the European Commission is doing and stimulating the Parliament to develop rules, and that is an area. On the other side is how we equip, we form the manager to be prepared to work in these environments that became more and more virtual. So which type of competencies we need to work in teams, as it was said at the beginning, so to know the knowledge of the data, the knowledge of the AI system in technical way, in the algorithm, and the potentiality of the algorithm, and at the same time the law and how to create a business model that consider also the value that I have to create for the society, for the people, for my business. So the three different level of impact. So definitely the sovereignty and the governance is one of the critical issues that need to be strongly considered. We have no answer, but issue and the different stakeholders have to put around the table to discuss together and to contribute to define the rules of the game in a proper way.
So one of the steps to virtual worlds is maybe digital twins, environments that represent the physical reality of the power plants, for example, or the systems that we work with. That's an area that you, Yves, have been working on. And how can you combine AI and simulations with digital twins?
Mm-hmm. Yeah, I've been working on digital twins for a while, and indeed, Cyril, you've mentioned, and has been also a pioneer in some of the smart cities digital twin, for example. Here was what is interesting in the energy sector, and that's something we're applying at AI Redefined, is to be able to to actually fine-tune some generative AI, not only by the human feedback, but actually by also interacting with the digital twin of your operations. So when you're actually asking a question or you're prompting something, then your algorithms can actually leverage a digital twin of your operations and do a myriad of different scenarios analysis and come back with maybe the rank of the different recommendations that are actually grounded in something very physical, very tangible. So it's really now a super team, not only with AI agents, humans, but also with those digital twins. And digital twin, we see that, we see what it is when it's, for example, a digital twin of a city, of a plant, maybe of a solar farm. But a digital twin can be also very abstract. And coming back to what I was referring before, that can actually be all the processes you have internally in your organization. And you create a digital twin of that and see what are the responses of different scenarios you're trying and coming back with the most probable outputs. So that's really, I think, an upcoming field. And that's, a lot of organizations have, especially in the industrial sector, have digital twins, somehow. But I think that will be an increasing trend because of this strength of being able to ground everything we are doing in reality and to test. So then you can create data, coming back to what Jan was mentioning before, this generative AI plus the human plus this digital twin will actually upgrade the level of data you will have, and you will get, by continuous learning, even more accurate answer to that. So you don't have to wait for perfect data, perfect organization, perfect objectives. You actually go, you run, and you start actually improving everything on the run. And I think that's also a fantastic opportunity, maybe for smaller organizations who are part of this energy ecosystem as well. I'm referring to small, medium enterprises, for example, that don't have a lot of data. They have expertise, they have processes, but they don't master everything around them. So that's a fantastic opportunity for them to see what will be the reaction of the ecosystem. And there is a real, a genuine role for very large organizations like ENGIE to actually be the leader of those ecosystems and help their suppliers to be even stronger and even more efficient for them.
Interesting. So we talked about traditional models which use small data or smart data, LLMs that use big data, and that's maybe something to open up the discussion around. Have we reached the peak of LLMs? There's some discussions around that because LLMs have basically trained on virtually all the internet as we know it. Ingesting even copyrighted material, etc. So there's starting to be boundaries now set. The level of data that can be used for training is probably going to reduce, especially with especially with new data being generated by LLMs themselves, which means that maybe it's not as useful for training models. How do you see the evolution of generative AI and LLMs based on this premise? And how do you see the technology evolving from here? Maybe Jan to start.
So I won't necessarily want to answer that specific question because the underlying question is about value capture. And so as human beings, I believe that we are, as a society, we're not ready for one given company to capture all of the human knowledge and transfer it as a way of providing service and capturing the value. Now, the substrate is this notion of commons, open source, open weights, and common corpuses, right? So if the data out there belongs to everybody, then it should remain that way. Therefore, all of the models that are derived from it should be the property of everybody. But that's not the case. And the underlying topic is one of sovereignty in the military sense. So you've probably noticed we live in a dangerous world. We had an interesting sequence, to say the least. Trump won, America first. Then we had COVID, where Europe realized that we couldn't produce masks. Then Russia attacks Ukraine at our doors, and energy becomes a topic of interest, more than that. So we are, of course, dependent on energy, which is infrastructure. And now Gen AI, where we see that you need billions to actually bootstrap a new type of technology, which is, of course, very promising. Now, this sequence should tell us, Europeans, I assume a lot of us are Europeans here, that as a construct, if we think that Europe is a great place to live in, that we should defend, that democracy is a worthwhile construct for society, what does it mean to be sovereign, right? So, and so these LLMs, so of course we have Mistral, but come on. Mistral is raising money from large US investors. This company is worth more than $2 billion. Who's going to acquire this company? This company is mostly American, but that's good. It's good for the founders, it's good for the company itself. But in terms of the dependencies, in terms of capital, in terms of compute power, you know, did you see Llama 3? Llama 3 is using, what, 26,000 GPUs at once? Who can afford 26,000 GPUs? And the energy that goes with it and pay for it? So this notion of sovereignty is linked on the entire stack. The notion of commons is largely being captured by the usual suspects. And so how do we ensure, and typically, so tell me if I don't know this, I think NG is an OIV, is that correct? It's a secret. So we will assume for the argument that NG is important, right? Okay, for France. But the NGs of the world are important for each nation. That is called infrastructure. And technology, it's funny because GPT means a generally pre-trained transformer, but GPT also means general purpose technology. General purpose technology, once it's adopted, is actually infrastructure also. So AI plus compute is infrastructure, and the question is not so much what's happening with the next LLM, Llama 4 and GPT-5, whatever, frankly. In fact, all of these companies are just competing with themselves. All we need is to just grab whatever works. But the point is, where does it run? Where is the data? Do we control it? You as decision makers are decision makers to decide whether to create an additional dependency or whether you create additional resilience in line with NG if it is an OIV. We won't say. But the point is, this notion of free will, because we have free will, is also a notion of understanding the dependencies so that we can make the right choices regardless of the technology. AI is software. That's it. But software is infrastructure because of this dependency on compute. So either you remove the compute element and you are frugal and you run on your actual capacity, that's great. Maybe you can use open source, which is, of course, my plea. I'm an entrepreneur. I've been in tech for 40 years. I've been an entrepreneur for 25 years. I did not create a big tech, a GAFAM. You would know about it. That's not the case, let's be clear. But the French ecosystem did not create a big tech either. And guess what? Europe also failed at creating a big tech that captures all of the value. So my vector is about commons. How do we ensure to distribute commons, data sets, software libraries like scikit-learn, to as many people as possible to empower them to own their data science, their machine learning, their stack, so that we minimize the dependency to be more resilient if, for instance, Trump too decide to be angry with Europe. Because right now, I'm assuming that a lot of you depend on Teams, which is a great company. You know, Microsoft is a great company. There's no problem with that. The thing is, as much as we depend on energy, we also depend on this technology that harnesses the juice out of it, right? Technology helps optimize processes. So we need that technology to milk the most out of the energy grid. We need to milk the most out of the resources, the limited resources that we have, right? How do we maximize energy, as you said, in a battery? So it turns out Apple is pretty good at it because they optimize batteries with 1 billion devices out there, right? So a lot of data helps companies optimize. So how do we harness what others have done, turn it into general good, general interest? At the end of the day, our job is to ensure a better society for our children. That's it. So how do we create resilience? And I think, and that's to your point of governance, how do we build into the processes that we build, into the AI that we consume, the proper resilience in terms of risk management? And that is something that is quite dismissed today. Although we do have the AI Act that is coming to the rescue. So Europe is really good at regulating, unfortunately. That is our strength. But we need to leverage other muscles as well in terms of understanding, making the right decisions with regards to the right tools. This may not be great for IT management because it's a difficult task, very difficult. It's much easier to choose Microsoft. Nobody ever got fired from choosing IBM nor Microsoft. But try, please.
So thanks so much. I think it's a good time to take a couple of questions from the audience. We have some mics that... we have people in the online as well. So,
oh, okay, thank you. Oh, well, really very interesting questions. I mean, introductions and some great one-liners. I also wrote down. So I like this literary GPT or literary AI. Just a couple of questions. I think it was actually motivated by your last question on the AI Act and I guess the interaction with different types of models, in particular open source models. And I think it might be useful to point out that there's different levels of open source. I mean, I think most of us haven't seen the source code for most of these actual models. Yes, we have pre-trained models. Some of them can run on very small GPUs, which is impressive, and they often have performance that is surprisingly close to the frontier. So that's perhaps adds a moment of caution to some of the things about the direction that the AI has gone. I guess so just in terms of integrating these things, and sort of a related question is, where do you see Europe going and how the regulatory environment may interact with its progress or lack of progress? I mean, for instance, today I tried out the Meta AI glasses and I discovered that there's no AI features because I am sitting in Europe, and in fact I have to be sitting in the US to be able to use the AI feature. So I thought it was quite a vivid case of, I thought Llama 3 might be like fully deployed on these glasses, but no, they only take pictures and play music. So how do you see the interaction of the regulatory environment with sort of where we're headed here?
Yeah, maybe I can start answering. Personally, because I contribute in the European Economic and Social Committee, which is strongly related to this regulatory environment, I see a strong presence of Europe. You mentioned the AI Act is already there. Europe was one of the first with the GDPR, which is very accurate in the privacy compared to maybe other areas, CDMA in US or Asia. I see a strong willingness to put some boundaries, to define rules Of course, the technology is going fast. Also, the evolution. I'm talking. One thing is the AI Act, that is a discipline of AI, and the other is the virtual worlds. So different ecosystem, more complex, where it's boundaryless, and the fact that it's boundaryless poses a lot of issue. In terms of harmonization with other area, because it's boundaryless for technology, and so how we can define rules only for Europe, they need to be harmonized with US and with Asia. So, I mean, the technology is going fast, but the regulation is also following with different steps that maybe we don't see with the same fast path, but there is a strong attention also in the action, because if you look at also what the European Commission is doing, is promoting now several grants, several action to stimulate the development of the society, the development of the entrepreneurs that work in this area, empower the different actors. On the other side, the European Parliament is working in issuing rules. But definitely we are talking about a very complex environment that need harmonization with different continents. I mean, maybe.
And Sean works at OECD, so he may help influence some regulations, maybe.
So a quick comment on that, or reaction, rather, which is that I'm not satisfied with the level at which Europe is playing. I have no problem with the US. The US does what it does best, and technology coming out of the US is great. The thing is, the US and Europe should be sparring partners. That's not the case. Europe is a junior partner, and that's not acceptable to me for the future generations. And I think Europe is regulating because it's trapped in its own game in free markets. That should be the case for within Europe. But the US is protecting its interests, and also America First really states the thesis that it's against China. Again, I have no criticism of either the US or China, two different models that compete with each other, but we need this world to work. And so I'm thinking that Europe should be at the level of the US because we share common values, and therefore technology will shape society tomorrow. So regulation is only a short gap measure. It's usually late, and it's insignificant in many ways. So of course, GDPR was the first thing. DMA, DSA is a little more, proactive in some ways. Still not sufficient. We need to step up to be the sparring partner that we need to be with the US to defend democratic values, open markets, not free markets, because it's imperfectly perfect. And to me, that is the issue. The issue is that we need to muscle up, harness capital, build up the common market to actually be one, because the US has the depth. Silicon Valley is actually 7 generations of funds returning money to investors. We idealize Silicon Valley as being the bedrock of technology. No, it's the bedrock of finance, creative finance. And we need to step up that cycle so that we end up at a point where we actually challenge each other in terms of technology. Because right now, sovereignty can be measured in France. It's pathetic. It's 1%. Our level of sovereignty is 1%. So of course we try to regulate, because we don't allow ourselves to do protectionism, liberal protectionism, which would be the right term, right? You protect small players so that they become relevant, not protect them to protect some turf. That's not desirable, not even in the US, in fact. Big tech is a problem in the US as well, because it captures too much value, it doesn't allow innovation. But across the industries, you don't have a level playing field. That is the issue, and currently regulation is all we have, but it's insufficient.
Yeah, and I think that regulation is always the problem is mostly the pace. In Europe, we have what they call the shapers and the makers. So basically, the regulators and the people in technology and business, and they've tried to do some crucibles, so some sandbags, in order to analyze all that, and in order to understand what should be regulated and not. Technology or applications, so it becomes obvious. But I think that all this work that has been done in Europe at the Council of Europe, for example, where I had the privilege to sit at some point, where we're trying to understand the the level, well, the impact of the technology on the rules of law, the democracy, and the human rights. And that's referring to what you were mentioning before. That's the common values we want to have, well, that we have in Europe, and that we are, for some of them, sharing with the US. And if we see the European AI Act and the UN resolutions that actually came out the 23rd of March this year, that was strongly inspired by all the work that we've done. And to your point, in the US, they've also realized that, some sort of boundaries are required if we want to protect our society, our companies, and our values. And that's maybe a point that is interesting along with the sovereignty. So we have the national or the regional sovereignty, and there is this form of company sovereignty or corporate sovereignty that we can have as well, protecting our data, our knowledge, maybe our super teams of digital twins, AI agents, and human experts and operators in the field. So how to protect that? We will indeed run probably on computers that will be, where the value will be captured elsewhere. But there is a tremendous wealth in all the operations, the domain expertise, the industries. There's very strong corporations that we have here in Europe. And of course the people. So how to bring those human values into AI systems? That's actually a paper we've written for HBR as well. That was released last month. That's I think where every country, every company will have to work on. And human values are also what are the corporate values we want to inject in our product. Because at the end of the day, we will be accountable of the possible side effects it could have, those AI systems could have once deployed. But we also want maybe to shape a bit the way those technologies are used, and that reflect how we want our society to behave. And indeed, those energy grids, those infrastructures, are critical system. So that the European Act have different level of risks, and those energy infrastructure are not at the lowest rank, such as the spam filters, for example. They're not at the highest either. Higher risk is where you have manipulative type of algorithms and social credit, for example. But that's just below, because we have consumer data, and we have a critical infrastructure to protect. So I think that, again, there are a lot of opportunities, a lot of unknowns. We need, and thank you, Jan, again, for bringing this awareness about the sovereignty in a passionate way. But there are a lot of opportunities that are coming for the students that are in the room, the young professionals, and the others as well, in how we will use in a better way AI within the organization. Maybe not doing those pilots or POCs that are just acculturation, but maybe go for where the impact will be and where the revenues and the productivity will be.
Thank you. Maybe time for just one more question in the audience.
Hi, everyone. Just one question. Maybe it's micro question because this is macro question. How we can challenge AI, the result provided by AI? Until now, we have the possibility to debug the code step by step, or follow the demonstration to challenge the result. How we challenge currently the result of AI?
It's explainability, maybe, if you want to say a word on that.
So I ran an experiment about a year ago where I asked ChatGPT to write my senior thesis from 30 years ago. And so I asked one question, I got the result in 10 seconds. I ran the code in Python, and there was an error in the middle. And I said, great, This is when I step in, right? And then I repressed my reflex by saying, ChatGPT, you made an error, fix it. ChatGPT apologized, gave me the fix, and it worked. So this notion of interaction is actually another way to think about debugging. And ChatGPT, the first version, didn't have any introspection. Now the versions that came after from Microsoft linked to Bing provides introspection and links to the sources in the argument. So all of the technologies that have been mentioned earlier, the agentic approach where you have agents collaborating on numerous ideas in parallel, it's just like your left brain and your right brain working together. These things help you process information, provide insights, and so we can force these new types of AI to produce explainability to some degree. And you have other companies who are also working from the models, and they try to look at it from the outside, just like you are a brain surgeon and you're opening the brain to see what's happening from the outside. So everyone is working on these techniques so that we end up with models that actually reassure human beings. They may be working flawlessly, but we still do want to understand. So just make sure that you are patient a little bit to let the engineers and the researchers come up with the tools that are making the technology compliant with things like the AI Act, but also reassure decision makers. Right? You don't want the technology to just do things on its own, because we need reassurance. Just like, you know, Tesla comes up with self-driving cars, we're worried, even though we know that statistically they drive better than we do. Right? So this notion will take time, and we will need the reassurance, and that comes with more engineering and more reverse engineering. So maybe you can complete on that.
Well, I mean, that was already pretty exhaustive, but it reminds me of, you know, a new type of job that was in Courrier International. So I forgot what was the original source, but that's a psychotherapist of AI. So I say, what do you mean? I mean, an agent that will be my psychotherapist? Or no? No, that's actually the same as, you know, a psychiatrist will do, you know, what is the output? Where does that come from? What are the possible events, you know, in the sources that we feed the model with, or we fed the model with, that gave those outputs? So having those kinds of questioning in order to understand better what will be the results, and again, having those loops of reinforcement or learning will be the way to see if the model will remain within the boundaries of what is acceptable or not. And then you can, you know, unfold and go back to the sources and do this those more engineering tasks.
And you work a lot on AI in the education sector, right?
Exactly.
Yeah.
I wanted to make this comment. This implies, of course, a multidisciplinary teams, because I cannot control everything. And so make people talking, and data scientists have to talk to manager. So this multidisciplinarity, the ability, but of course also in the education you mentioned, needs to create new competencies to form the managers of the future, is MRUF, which is an acronym that distinguishes a new generation of managers that need to develop new skills and new competencies to work in this AI-enabled environment and AI-enabled task.
Thank you very much. Ludo, would you like to say a few closing words?
Yeah, so it was very inspiring, and for what you say, Margarita. I used to say in my team that IT, digital, is a team sport, so I'm pleased to hear that you agree with that as well. And for me, what was striking in this conversation is all the potentials that we have in the future, some risk, and thanks, Jan, to remind us that I'm a senior manager in IT. We are using Azure, we are using AWS massively.
Which is fine, they're great.
Yeah, I know, but even sometimes I'm asking myself some question about that. And And my last takeaway is from my former team in energy management, where I have a representative here. We need to think about using GenAI to optimize the power network. And it's something that we have not yet opened, and I will take this one as an action.
So about a year ago, we used to have a few discussions in cafes, having drinks with a few members from here, Jan and Eve, and I met Margarita before as well. And we used to discuss about AI, and I thought that if I wasn't part of those discussions, I would love to be a fly on the wall and hear what was being said. So the idea for this cycle of conference emerged in terms of sharing with everyone here the discussions that we had, trying to be as conversational as possible, trying to explore different dimensions. And I'm really pleased that we started somewhere, ended up somewhere else, and explored a lot of different topics in how AI will influence our work life, our personal life, the risks and challenges, like you mentioned, and the opportunities, and the link between energy and AI, both as in the supply chain, as energy being critical to AI systems, but also how AI can help support the energy transition. And that's something that we'd like to continue exploring. So we'll have a few discussions in the next few months on AI. So the next one will be at VivaTech. If those of you participate there, we're exactly setting up the schedule. We'll discuss with startups that are involved in the energy sector on how AI can leverage, how can we leverage AI to help contribute to the energy transition. We'll have another session that will be scheduled here in June, 25th of June, with another panel discussing about ethical and regulatory considerations, which is sort of where we ended up here. So it's a nice transition to the next few events. If you want to be part of the community, I invite you to flash the QR code here and also give us your feedback on this session. Email us. We're really pleased to have you here, and we'd like to continue the discussion for those of you who are physically here outside the room with a few drinks and bites. And for those of you who are online, thanks for joining. We'll be posting this video and open it to the public so that we can get the conversation going. But really, the idea of bringing everyone together from different walks of life is to really get this momentum around having a community around these topics. So thank you, everyone, and see you soon.